Hello everyone, welcome to Wallah. I hope everyone is doing great. So, in today's lecture, we are going to practice questions based on your hydrology, irrigation, CPM part, and BMC. Okay, so from these four subjects, we are going to discuss questions today. Okay, so the topics which will be covered in today's lecture are hydrology, irrigation, construction management, and BMC. Okay, so before starting, everyone kindly comment if I am fully audible and visible. Then we'll start our lecture, and it's a request to everyone kindly share the lecture. Okay. So am I fully audible and visible? Kindly comment everyone, and it's a request that everyone solve with me. Okay, everyone will solve along with me. So this is your very first question. This is your very first question of hydrology. So in this question you can see the ordinates of 3R hydrograph of a catchment area of 30 kilometer square are given below. Okay, so these are the values which are given to us. These are the 3R hydrograph values. Okay, this is your flood runoff hydrograph. This is your flood runoff hydrograph which is given to us. Then base flow is given to you. And these discharges are happening at a time of 5 a.m., 8 a.m., 11 a.m., 2 p.m., 5 p.m., 8 p.m., 11 p.m., like that. Okay, and so on and so forth. So you can see flood runoff hydrograph is given to you, base flow is given to you, and time is given to you, and we are required to find direct runoff depth. So how we will find direct runoff depth? What approach we will use? Try to solve it. See, basically you need to understand, if I want to find direct runoff depth, if I want to find direct runoff depth, then what I have to do? I have to find the volume of direct runoff. I have to find the volume of direct runoff. Okay, and divide it by the catchment area. So volume of direct runoff divided by catchment area. So catchment area is given to us. Okay, you can see that catchment area is given to us as 30 kilometers square simply. But volume of direct runoff we don't know. And the concept which will be involved here is that, see, this is your flood runoff hydrograph. This is your flood runoff hydrograph. Okay, and this is your base flow. So from this flood runoff hydrograph, we will subtract base flow and obtain DRH and obtain direct runoff hydrograph. And the area under that direct runoff hydrograph is nothing but volume of direct runoff. Okay, is this thing clear? So area under your direct runoff is nothing but volume of direct runoff itself. So see, if we want to find volume of direct runoff, we have to find area under the DRH. We have to find area under the DRH. So how we will do that? Let's take one more slide. With the help of that, we'll do it. Okay. So firstly, we have to subtract FRH from base flow, because you know that DRH ordinate, okay, direct runoff hydrograph ordinate is given by, see, these questions are very important for gate. Okay, these questions are very important for gate. They can be directly asked there. Okay, so direct runoff hydrograph ordinate is nothing but FRH minus base flow. So we will simply do what? We will subtract them. Okay, so we'll subtract 14 minus 14 is 0. Okay, we can subtract it and get the values of DRH. Okay, we can subtract and get the values of DRH here. So what we will do? 14 minus 14 is 0. 25 minus 12 is 13. Okay, 51 minus 11 is 40. 65 minus 10 is 55. 54 minus 11 is 43. This is 10 and this is 0. Okay, so these are the ordinates. So we have a graph. See, 5 am, 8 am, 11 am, you can see that the time gap between all of them is 3 hours. Okay, you can see this is 3 hour gap. This is also 3 hour gap. This is also having 3 hour gap. Okay, so 3 hour gap is there between all the time ordinates, and now we will plot them. Okay, so we can say that this is time equal to 0. This is 3 hours, 6 hours. This is 9 hours, 12, 15 and 18 and so on and so forth. So we will draw this. We will draw this graph. Okay, we will draw this graph. So the very first one is the first value which we can see here is 0, then 13, then 40. So 0, 13, 40, 55. This is 0, then 13, Let us say this is 13. Okay, then we have 40, then 55, then we have 40. Okay, then we have 40, then we have 55. Okay, so at a gap of 3 hours, we have all the ordinates here. Okay, this is at 9 hours. It's from starting. Okay, 55. After 55, we have 43, 10, and 0. After 55, we have 43. Okay, let us say this is 43. Then we have 10. After this, we have 0. Okay, so these are the ordinates. Okay, or you can say this is 5 a.m. This is 8 a.m. This is 11 a.m. 2 p.m. 5 p.m. 8 p.m. and 11 p.m. again, like that. Okay, so these are the times which are given to you here. Okay, so this DRH is done now. DRH is done. We can simply join it. We will simply join it. Okay, like this. You can simply join the ordinates directly. Nothing tough. So this is your basic direct runoff hydrograph. Okay, now what we have to do? Now what we have to do? You have to understand. Yes, great. Good evening, dear. Good evening. Great, great, great. Now what I have to do, Priyansh? Okay, now what I have to do? I have to find the area under it. Okay, so we are going to find area under DRH. Why? Because this area under direct runoff hydrograph will give me volume of direct runoff. Okay, will give me what? It will give me volume of direct runoff. Okay, yes, clear. So how I will find area? It's very simple. If I want to find the area directly, we have one trick here. What we can do? We can find the sum of all the discharges. We can find sum of all the discharges ordinates and multiply it by the time between each between each and every discharge ordinate. We can multiply it by the time. So we can do this, or simply you can find area of each and every one. Like let us say we want to find second area, this area. Okay, so how I will find this area? Simply half into sum of parallel sides. Sum of parallel side is 13 plus 40, and into distance between them is 3 hours. Into 3 hours, like this. Like this, you will find the area of this graph, of this trapezoid, like this. You will find the discharge of all the segment, and you will add them. You will find this area of each segment, and then you will add it up. Okay, so I hope you know this. Okay, this is very simple. So what I will do here, and if you will sum it up, you will see that this formula will ultimately come. So we can directly sum up the ordinates. So sum up all the ordinates. So 0 plus 13 plus 40 plus 55 plus 43 plus 10 plus 0. Okay, this is in meter cube per second. And what is the time gap between each in each area? 3 hours. Okay, multiply by 3 hour. R, you all know, we can convert hours into second. You all know that in 1 hour we have 3600 second. Okay, so this second and second will get cancelled, and you will get the answer in meter cube. So how much it is coming? Yes, how much it is coming? Wait a second. Yes, this will give me answer. This will give me the answer somewhere around 13 plus 40 plus 55 plus 43 plus 10 into 3 into 3600. This is 1773. Yes, you also solve it simultaneously, dear. 1738800 meter cube. Okay, this is your total volume. Is it the same? Yes. So this is, yes, 483. 483 is meter cube per second R. Okay, but if you'll convert R into seconds, then you will get this much meter cube. Okay, I hope this is clear to you. See, 3 hours we have converted into second. Okay, yes, great. Now what we have to do? We have to find the direct runoff depth. we have to find direct runoff depth. So simply divide volume of direct runoff by the catchment area. So volume of direct runoff is how much? 173,8800 meter cube divided by catchment area. Catchment area is given to us as 30 kilometer square. You can see there 30 kilometer square. Convert kilometer square into, 1 kilometer is 1000 meter. You all know this. Very simple. So square it, and if I will square it, we have to square it here also. So 1000 square is 10 power 6. 1000 square is 10 power 6. So divide it, how much you are getting? Divide it, get the answer. Yes, perfect. So how much we are getting here? When I will divide 173,8800 divided by, this is giving 0.05796 meter. Convert it into centimeter, multiply 100. So it will be 5.796 meter, centimeter. See, meter, if you want to convert into centimeter, you will multiply it by 100. Okay. Yes, this is the correct answer. So the direct runoff depth will be 5.8. Okay. This can be roughly, it can be rounded off to 5.8, obviously. So A will be the correct answer. Okay. I hope this is clear to you. Simple. This is simple. Okay. Now we will move on to the next question. So this is the first question. Now we have one more question. Okay, the second question, which is saying a triangular unit hydrograph has a base time of 16 hours. Okay, so we have a triangular unit hydrograph. Try to solve this one. Try to solve this one. We have a triangular unit hydrograph which has a base time of 16. Okay. This is your triangular unit hydrograph. Okay, sir. Now what it is saying, it is having a base time of 16 hours. It is having a base time of 16 hours and corresponding area of the catchment. Catchment area is also given to us. Base time is given to us. Determine the peak of flood hydrograph. Okay, base flow is this much. Phi index is also given. Precipitation is also given. Okay. Very simple. Now, one thing which is not given here is the peak of unit hydrograph. Okay, we are not given in this question the peak of unit hydrograph. Peak of this unit hydrograph we don't know. So how I will find the peak of unit hydrograph? Okay. Yes, perfect. F peak is equal to unit peak into ARD. Perfect. Plus base flow also. Okay, Priyansh. Plus base flow also, na? So first we have to find the peak of unit hydrograph. So how we will do that? We have to apply the formula here. Okay, area under DRH is what? Half into. First we will find discharge, peak discharge, unit hydrograph peak discharge. So half into peak discharge into base time is equal to catchment area into effective rainfall depth. But this we have applied for unit hydrograph. Okay. This we have applied for unit hydrograph. So we will apply half. We are interested in finding peak discharge. Base time is 16 hours. So we'll put 16 hours. We can convert in 2 seconds. You all know that in 1 hour there are 3600 seconds. Simple. Catchment area is how much? It is given 80. Kilometer square is 10 power 6 meter square. Effective rainfall depth is 1 centimeter or 1 by 100 meter. Okay, 1 centimeter. Why? Because this is unit hydrograph. This is unit hydrograph. So tell me what peak discharge we are getting here. How much is the peak discharge you are getting here? Kindly tell. How much is the peak discharge which you are getting here? Tell me. The peak discharge which you are getting here is divided by into 2 divided by 16 divided by 3600. 27.77. This is coming Excuse me. Okay. This is coming out to be 27.78, I guess. Okay. This is coming out to be 27.78. Okay, like this. Okay, now. So we have found out the peak discharge of unit hydrograph. Okay, we have found out the peak discharge of unit hydrograph. Now what we have to do? We have to find peak of flood runoff hydrograph. So flood runoff hydrograph peak is nothing but we have to apply the direct formula. See, unit hydrograph peak into effective rainfall depth. Effective rainfall depth is not given to us in the question. So how I will find effective rainfall depth? Simply by subtracting infiltration from your total rainfall. Okay, it is given, and your base flow. This is DRH peak plus base flow. Okay, this is the formula which I have told you in class. You have to remember this formula, very very important. Okay, most of the questions you will be able to solve from this one only. Okay, I hope this is clear to you. So unit hydrograph peak you have just now found out. You will put it here, 27.78. Precipitation value is given to you as 5.5. So we'll put 5.5 centimeter minus infiltration loss is given to us as 0.5 centimeter per hour. So in every hour we are losing 1.5 centimeter hour. Okay, and what is the duration of rainfall? Duration of rainfall they have not mentioned. Triangular 1 hour unit hydrograph should be there. They are not given. Let us take it as 1 hour. Okay, let us take it as 1 hour. Otherwise duration should be mentioned here. Okay, duration of rainfall should be mentioned, or at least they should have mentioned here that it is a 1 hour unit hydrograph. Then from reading 1 hour unit hydrograph, I will understand that duration of rainfall is 1 hour only. Okay. Thank you, dear. Yes, now. So solve this, how much we are getting, and base flow is given to us as 15. Base flow is 15. Okay, base flow is 15. So solve this, how much we are getting? So 27.78 multiplied by 5 plus 15 is 153.9. 153.9 meter cube per second. Okay, so this is your peak discharge for flood. Yes or no? See, remember this formula. This is very very important. Okay, this formula is very important. With from this directly questions will be asked in your GATE exam. Okay, this is very important. I must have told you when you have studied it from me in the class. Okay, I must have told you that this is the very important formula. Okay, so remember it. See, in this question, in this equation, you can see 1, 2, 3, 4, 5, 6 parameters are there. Mostly in questions, you will see that sometimes unit hydrograph peak will be there, and this will be asked. Sometimes this will be there, and unit hydrograph peak will be asked. Okay, most of the times, this type of questions are there. Okay. Okay, thank you, Priyansh. Now we'll move on to the third one. I hope this is clear. So in this we have found out the area under DRH again, area under unit hydrograph again. Okay. So this area kind of things many times have been asked in exam. So it can be asked this time also. So you need to remember that mostly in of all the hydrograph questions, you will be asked area under DRH only. Okay. Most of the times you will see this is asked. Okay. Okay. Now we'll move on to the third question. So this is your third question. You can see. So what they are saying in this question, read out the question, try to solve it. So we have a storm with 12 centimeter precipitation, which produced a direct runoff of 6.1 centimeter. Okay. So 12 centimeter precipitation is there. Direct runoff of 6.1 centimeter is there. Duration of rainfall is 20 hours and its time distribution is given below. Okay, so this is your cumulative rainfall. We want to find the phi index of the storm. Okay, so this is a question which is based on your phi index. Phi index is also very important topic from GATE point of view. See, in this question, first you need to understand that you are given cumulative rainfall. Okay, you are given here cumulative rainfall, so you have to find incremental rainfall first. After that we'll see how to find phi index. Okay, first we have to find the incremental rainfall, like what rainfall will occur in the first 2 hours, like that. Okay, so we have to subtract each and every value here. Okay, we'll subtract each and every value. So in the first 2 hours, see, this is cumulative value, so subtract. So in the first 2 hours you will see the incremental rainfall is 0.4 centimeter only. In the next 2 hours you subtract this, the value of rainfall is 0.9 centimeter. In the next 2 hours, the value of incremental rainfall is how much? 2.8 minus 1.3 is 1.5. In the next 2 hours, subtract 5.1 from subtract 2.8 from 5.1, so it will be 2.3 centimeter. Then subtract this, you will get it as 1.8. Subtract this again, you will get this as 1.6. Subtract this, you will get it as 1. Subtract this, you will get it as 0.5. Subtract this, you will get it as 1.5. And subtract this, you will get it as 0.5. So these are the values of rainfall which are happening in consecutive 2 hours. So in the first 2 hours, you can see this is the volume, this is the value. In the next 2 hours, this is the value. In the next 2 hours, this is the value. Like that, you can get it. Like that, we are getting the values of rainfall in each and every consecutive 2 hours. Okay, in each and every consecutive 2 hours, we are getting the value. Yes or no? Simple. In each and every consecutive 2 hours, we are getting the value. Yes or no? Now we have to find the intensity. Because I told you that without intensity, we will not proceed in phi index question. Now we have to find your intensity. Okay, so how I will find intensity? See, 0.4 centimeter rainfall is happening in 2 hours. So intensity is what? Intensity is nothing but depth upon time. Rainfall depth upon time. So simply divide them by 2. Divide all these values by 2. You will get the intensity. So very simple, basic logic. Yes or no? So divide this by 2. It will be 0.2 centimeter per hour. Divide this by 2 also. It will be 0.45 centimeter per hour. Divide this by 2. This will be 0.75 centimeter per hour. Divide this by 2. This will be 1.15 centimeter per hour. Like this, you have to divide all of them. This will be 0.9. This will be 0.8. This will be 0.5. Then 0.25. Then 0.75. Then 0.25. Okay, so this is your, these are the intensities of rainfall. Now we have to find the phi index. So phi index is nothing but we have to take trials. Okay, we have to take trials here. So the very first trial which we'll take the first trial, and we'll assume that all the rainfall intensities are more than phi value. All the rainfall intensities are more than phi value. This is our assumption. Okay, and assuming this, we will find the first value of phi. Okay, so the formula for phi is total precipitation minus runoff upon excess time. Now total precipitation, simply sum up these values. Simply the sum is given to you already because you have subtracted from there only. So the total, okay, precipitation is given to you as 12. Already it is given to you in the question. Okay, so we will write 12 centimeter here. And runoff which you can see here is 6.1. Okay, runoff which you can see here is 6.1. So we'll subtract from total precipitation runoff and we'll divide it with the total time. Total time is how much? 20 hours. Total time is 20 hours. Now wish, I really wish that the value which I am getting is less than all of them. Otherwise, we have to take another trial. Okay, if this 5 value which we'll get here, if it is less than all these values, then it is okay. Okay, how much it is coming? How much it is coming? You are saying 0.295 Priyansh. Okay, great. Let me also solve it. So we are getting it as, yes, it is 0.295. Now, one problem is there. One problem is there that this value is more, this value of 5 is more than this, is more than this also, and this one also. Okay. So three intensities of rainfall are even lower than our first 5 value. Three intensities of rainfall are even lower than this 5 value. That means our assumption is wrong. Our assumption is wrong. Otherwise, this would have been the correct answer in the very first attempt. Yes or no? Yes or no? Tell me. So what I have to do now? What I have to do now? I have to subtract them now. Okay. Now what I have to do? I have to subtract them. So we will take second trial. We will take second trial, and in this second trial, what we will make sure that from this total rainfall, this one, this one, and this rainfall are removed. Why? Because they are less. Okay, whatever values will be less than 5, we will remove them. Okay, this intensity is less than 5 or equal to 5. If it is less than equal to 5, if this is less than equal to 5, we will remove them. So from total 12 centimeter, you have to remove them. So from total 12 centimeter, you have to remove them. Remove 0.4, 0.5 and 0.5. This will be removed. So 0.4, 0.5, 0.5 is 1.4. Okay. Or we can write it separately also. Let me write it here in the next line. So from total, you have to remove 0.4, 0.5, 0.5. Now this is your net precipitation, and now we will remove runoff. Okay, now we will remove your runoff. But now the excess time is how much? Excess time is how much? See, excess time means the time duration during which your intensity of rainfall is more than your phi index. The time duration during which, see, this is E. E means excess. So the time duration during which intensity of rainfall is more, is in excess to that of phi, that time only we want to take. So we will not take this time. We will not take this time also. We will not take this time also, because intensity is not in excess. Intensity is not in excess. So out of total 20 hours, you can see this 2 hour, this 2 hour, and this 2 hour will remove. Okay, so out of this total 20 hours, okay, 2 hour duration, 3 times will be removed, because in that duration, your intensity of rainfall is not in excess, and we are interested in duration of excess rainfall. Yes or no? Yes, perfect. So how much we are getting now? Tell me how much we are getting now. So how much we are getting now if we will solve this? We are getting this as 0.321 centimeter per hour. Now check that if this phi index is less than all other remaining intensity of rainfall. So yes, 0.321 is less than this one. Okay, it is less than this one also, less than this one also, less than this, less than this, less than this, and less than. So now this is the final answer. Why? Now this is the final answer. Why? Because this phi index is less than all the remaining I. Okay, remaining I values, remaining intensities are more than this phi. So this is your final answer. We will stop the trial here, and this will be the final answer. Okay. So if you want to put the answer in centimeter per hour, answer will be how much? It will be 0.321. Yes, perfect. Hello, Vaibhav. Hello, how are you? So is this clear to you? Now we'll move on to the next one. Okay. Now we will move on to the next one. Okay. So this is our third question. Now, question number 4. Okay. So a hydrograph is drawn with three rainfall intensities 12, 25, and 12. Okay. We will draw it. Okay. We will draw it here. So a hydrograph will drawn. Simple. So 12, 25, 12, and each corresponding to 1 hour rainfall. Okay. No problem. So let us say this is your 12. Let us say this is your 25, just double of that, and this is your 12 again. Let us say this is your 12. Okay, so this is given to you. So this is 12, this is 25, this is 12, and each is having a duration of 1 hour. Okay, each is having a duration of 1 hour here. This is your intensity, which is in mm per hour. Okay, so total duration of rainfall is 3 hour. Okay, total duration of rainfall is 3 hour. A Horton curve is given to us, which gives the idea about the infiltration capacity of the soil. So the effective rainfall will be equal to, this is very simple question. Simply you have to plot these, you have to plot this graph. Okay, so if your infiltration curve is 6.8 plus 10.7 e power minus 0.95t, so simply put 0. See, at t equal to 0, when your time is 0, what will the value of f? We can put the value of 0. We'll put the value of t as 0. So anything raised to power 0 is 1. Now we'll add them. So 10.7 plus 6.8 is how much? 17.5, I guess. Yes, this is 17.5. Yes. So, and that to mm. Okay. See, because in this one, infiltration capacity is in mm per hour only. Okay. So 17.5. So when you have 0, the value will be starting from 17.5. Okay. 17.5. Yes or no? Very good. Hello, dear. I am reading the comments. I have already said hello, Vaibhav. If you have any doubt, you can ask here. Okay. Now, so now at t equal to 1, how much it is coming? At t equal to 1, put the value of time as 1 here. So how much we are getting here? Plus, how much we are getting? So if we are putting value of 1, we are getting it as 10.938. Yes or no? 10 point, yes, 10.938. So we can round it off to 10 point. Okay, we can round it off. Let us take it in 2 decimal places. So we can round it off to 94. This will be 94. So 10.94 will be where? Less than 12. Okay, this is your 10. Okay, 10.94 is less than 12. So obviously this value will be here. Okay, so this is your 10 point. You can say this is your 10.94. Okay, now no need to go for 12, 2, because at 2 value will be even lesser. So no need to go for it. You can simply do what? You can make a curve here. Okay, you can make a curve here. So now you have understood that this curve is cutting the first rainfall intensity. Okay, this curve is cutting the first rainfall intensity, but we don't know where it is cutting. Okay, sir, we don't know where this graph is cutting. So at what time it is cutting, that we want to find, that we have to find. So how we'll do that? What time this is? So we have to find that this graph is having a value of 12. See, this is 12. 12 at what time, that we have to find. Okay, so we'll put the value of 12 here. If f is equal to 12, if f is equal to 12, then what is the value of time? Then what is the value of time? So how we'll do it? Simply subtract 6.8 from 12 divided by 10.7. Okay, then take natural log on both sides. Okay, natural log on both sides will take and divided by minus 0.95. So we are getting the time here. We are getting the time here as 0.76, approximately 0.76 hour. This means that at 0.76 hour, this graph will cut this. Okay. Now, if I want to find the effective rainfall means the excess rainfall, So first we have to find how much is the total infiltration. Okay, great. Great, Vaibhav. So yes, 0.736 is correct. 0.736, no, 759 we are getting. Okay. We are getting 0.759, so we can round it off to 0.76. Okay, now see what we have to find. Yes, effective rainfall is nothing but total rainfall minus infiltration. So we will find infiltration. See, this is infiltration up to here and the area under this graph. Okay, we have to find this. So first we'll find this area. So total infiltration, how we'll evaluate? How I will evaluate total infiltration? So very first rectangular area is what? 12 mm per hour into 0.67 hour. Okay, 12 mm per hour into 0.76 per hour. This is your infiltration in the first 0.76 hour, where your infiltration curve is more, and you will say that intensity of rainfall is less. Since intensity of rainfall is less, all the rainfall will go into the ground itself. And here you will see that rainfall is more and the water which will go into the ground is less. Okay, so this infiltration, how I will get? By integrating it from 0.76 to 3. Okay, after this we have to integrate from 0.76 to 3. Ft is given as 6.8 plus 10.7 e power minus 0.95 t dt. Okay, solve this. How much we are getting? Solve this. How much we are getting? We are getting it as this. You are getting it as 9.12 mm. If I will solve this, we will get it as, see, we can solve this. We can put all the limits here. Okay, so 0.76, then upper limit is 3. Excuse me. Give me a second. Okay, so how much we are getting this integration? This integration is coming out to be 20.05. Okay, this integration is coming out to be 20.051. Okay, or you can, yes, approximately 20.05 mm. I hope you are able to solve it. So if you'll add them, this will be 29.17. So this is your total infiltration. Okay, this is your total infiltration 29.17. Okay, now find the effective rainfall. Effective rainfall means runoff. Now if you want to find effective rainfall or the runoff, now if you want to find effective rainfall or your runoff, okay, so how I will find? So from total rainfall I will subtract infiltration. Okay, now what is your total rainfall? It is very simple. See, total rainfall is 12, 25, 12. This is your total rainfall. Okay, you have to simply find the areas of area under your hydrograph. So 12, 25 and 12, this is your total rainfall and this is your total infiltration. This is your total infiltration. So how much runoff we are getting? Kindly comment. I am seeing your comments. So how much rainfall we are getting here? Yes, subtract it. 49 minus, yes, 19.83. Yes, perfect. 19.83. So I hope this is clear to you. 19.83 mm. Okay, so this is your question number 4. I hope this is very clear to you. Simple question. Okay. You can expect such kind of questions can be there in your gate. Okay, you can expect such type of questions in gate also. So this is your infiltration curve. See, infiltration questions are very important. Okay, infiltration questions are very important for gate point of view. Now we have question number 5, which is based on your Thyssen polygon method. Okay, so simply you have to do nothing. You simply have to find the average depth of rainfall. Okay, you simply have to find the average depth of rainfall. Simply apply the formula, get the answer. Okay. See, area is given to you, precipitation is given to you. So how you will find the average depth? How you will find the average depth? It is very simple. If I want to find the average depth using Thyssen polygon, I have to do what? Summation PIAI from 1 to n upon summation AI, total area. Okay, again from 1 to n. So simply do what? P1 A1 P2 A2 like that. So this is your P1, this is your A1. So P1 A1 25 into 15.4 plus, like this we will add. Okay, like this we'll add all of them. Then 37 into 49.8 like this. So total we will have 8 combinations here. So like this you will have it. The last one will be 40 into 11.5, 40 into 11.5 divided by total area. Total area is what? Total area is sum of all of them. And if you'll sum it up, it will be equal to 250 kilometer square because it is given in the question also. Okay. So it is given area of 250 kilometer square. So no need to sum it up. Simply write 250 kilometer square. Okay. See, the top numerator will be giving you the unit of mm into kilometer square, and bottom and denominator will give you unit of kilometer square. So this will get cancelled. Answer will be mm only. Answer will be in mm only. So I am giving you a minute's time. Solve it immediately and tell the answer. Yes, we are practicing it. So solve it and give me the answer. Okay. We have to do P1 A1 here. So How much you are getting? This is coming as, let me check, wait a second. This is coming as 41.75. Okay. When you will multiply them and add it up, this numerator will come as 1038.2 and denominator will be 250. So when you will solve it, you will get it as 41.75 m. Are you getting it or not? So this will be 41.75. Okay, so this is also very simple. I hope this is clear to you. Okay, no problem, no problem. Have you understood or not? Have you understood this or not? So this is your Thyssen polygon method. See, all the three methods, be it arithmetic mean, Thyssen polygon or isohydral method, all are important. Okay, you can expect any of them to come in your exams. Okay, so this is it. Now we'll move on to the question number 6. Okay, question number 6 is saying a bridge has an expected life of 35 years. Okay, sir, and is designed for a flood magnitude of return period 100 years. Okay, consider the following statements. The inbuilt risk in the design is this much. So we will simply apply the formula for risk. You all know what is the formula for risk. I hope you know it. The formula for risk is, we'll evaluate it here. The formula for risk is 1 minus 1 minus q power n. Okay, q is what? Q is what? Q is nothing but 1 minus p power n. Okay, q is what? 1 minus p. And what is p? P is what? P is 1 by t. P is what? Probability of occurrence is 1 by t. So this you have to evaluate simply. Okay, so 1 minus 1 by t. T is given as 100. Okay, return period is 100 here. And value of n is 35 years. Design life is 35. So n is 35, t is 100. N is 35, t is 100. Solve this, get the risk. How much risk we are getting here? How much risk we are getting here? 0.296. Yes, perfect. 0.296. That means this is the correct one. Okay, A option is correct here. Yes. Now consider the following statements. We have to check the second one also. If risk is 20%, they are saying if 20% risk is acceptable. Okay, if risk is 20%, then what is the return period? Okay, now let us solve it again. See, formula for risk is what? Sir, 1 minus 1 by t power n, like that. Okay, now they are saying risk is 20%. Now they are saying risk is 20%, which means 20 by 100 is 0.2. Okay, now I have to find the return period. N is how much? Okay, n is 35, same. Okay, in this we will take same value of n because they are not saying anything. So we will take the value of n as 35 years only, same. So what will be the, okay, so what will be the value of t here? Wait a second, put 35 here. Okay, solve this. So 1 minus 0.2, this will come here, this will be 0.8, then 0.8 power 1 by 35, then whatever will come subtracted from 1 and take reciprocal of it. You will get the value of t as how much? Solve it, how much you are getting? Tell me how much you are getting. So the value of t which you will get from here is 157 only. Okay, this is correct, 157. I have also solved it. We are getting it as 157 years. So when risk is given to you, n is given to you, you can easily find t. So this is also correct. 157 years is correct answer. Okay. Now we have to read the third statement. Third statement is saying dependability of an occurrence of 100-year flood is 1%. See, this is very simple. See, dependability means probability of occurrence of 100-year flood is probability of occurrence of 100-year is flood 100-year flood is 1 by t simply. Okay, 1 by 100 only, which means 1%. This is direct. Okay, probability of occurrence of 100-year flood is 1%, that is for sure. Okay, similarly you can find for any other return period also. Okay, simply you have to do 1 by t. So this is 1%. Easy. This is easy. So C option is also correct. See, this is MSQ. This is multiple select question. This is multiple select question. I hope this is clear to you. Okay. Now the last one, dependability of occurrence of 100-year flood in 15 years is 86%. So dependability of occurrence of 100-year flood in 15 years is C. If you want this flood, listen very carefully, if you want this flood to happen at least once in 15 years, okay, what is the meaning of dependability here? Like this flood will occur at least once out of 50 years, okay? So if you want this flood, if you want 100-year flood, if you want 100-year flood to occur at least once in 15 years, at least once in 15 years, okay, if you want 100-year flood to occur at least once in 50 years, so what will be the probability? See, this is, see, at least once is what? Risk. I've already told you that at least once is what? Is nothing but risk. Okay, so here we are interested in finding risk only. So find risk, and risk is what? This is the formula for risk. So simply put the values 1 minus 1 by t. T is how much? T is 100-year. T is 100-year. Value of n is given as 15. Value of n is given as 15. Simply find risk here. Simply find risk here. You will get the answer. How much you are getting? So the risk which we are getting here is 14%. Okay. When you will solve this, you will get it as 14%. Okay. 13.99 you are saying, perfect. So around 14%. Around or 0.14 or 14%. So this is wrong. So if 14% was written here, then it was correct, but it is written 86, so it is wrong. D statement is wrong here. Okay, so I hope this is clear to you. Dependability of occurrence is clear to you, like probability of occurrence of 100-year flood in 15 years. In 15 years, it could happen once or twice or thrice or 4 times or 5 times, likewise 15 times also. Okay, so we are interested in finding the probability for at least once, and at least once you all know is risk. And when your flood never occurs, that is reliability. When your flood never occurs, that is reliability. Okay, and you all know that risk plus reliability is 1. You all know that risk plus reliability is 100%. Okay, this relation you should understand. They are complementary. So this is at least once, this is never occurring. Okay, so I hope this is clear to you. Now we'll move on to question number 7. So this is your question number 7. Very simple question. This is question number 7. Here we have to find the missing rainfall station data. Okay, you can see from this table that actual precipitation at station X is not given to you, so we have to simply find it. Okay, so the very first thing is, what formula we have to apply? Will we apply arithmetic mean method or will we apply normal ratio method? For that we have to check 10% range, yes or no. So for that we have to check 10% range. So here we have 765. We will take 10% ahead and 10% below. So this is normal precipitation value of missing station. So first I will increase this value by 10% and then I will decrease this value by 10%. Okay, so when you will decrease it by, oh sorry, first you will increase it by first you will increase it by 10%, so it will be 841.5. Yes, and when I will decrease it, it will be 688.5. Okay, now check if all the other normal precipitation values are between these values. So is 1150 between this? Obviously no. 930 is between this? No. 1010 is between this? No. So since no value is lying in between, okay, if even one value is lying out of this range, then I will apply normal ratio. Okay, I will write here that since all the normal values A, B, C, D are not in this range of plus minus 10%, that's why I will use normal ratio method. That's why I will use which method? Normal ratio method. Yes or no? Perfect. Yes, so apply normal ratio method. See, normal ratio method is very simple. P by n values. P, this is P, this is P column, this is N column. Sorry, this is N column, this is P column, this is P, this is N. So P by N for A is how much? P by N for A is 900 by 1150. Then P by N for B is 850 upon 930. Then P by N for C station is 915 upon 1010. Then it is 780 upon 860. 780 upon 860. Okay, so take average of this, and this will be equal to precipitation of X upon normal value of X, and normal value of X is 765. Normal value of X is 765. So from here you will get the value of precipitation at X. Okay, tell me how much we are getting. Tell me what is the value which we are getting here as precipitation, as what will be the actual precipitation at X. How much we are getting here? We will get it as, if we will solve this, we are getting it as how much? 671.2. I am getting it as 671.2. Are you getting the same? Yes, perfect. Very good. 671.2. So this value we can evaluate, and we have estimated if rainfall would if we would have measured the rainfall, it would have been somewhere around this value only, 671.2 mm. Okay, so this is your final answer. Okay, yes, 19 you can round it off to 2. Okay, So this is your question number 7. I hope this is clear to you. Okay. Yeah. Now we'll move on to the next question, which is from subject irrigation. So this is your question number 8. It is saying a water course has a cultivable area of 1200 hectares. Understood, sir? So there is a water course and the area which is able to command it is 1200 hectares. Okay, so the water is reaching in an area of 1200 hectares when it is supplied from this water course. Okay, okay, sir. Now the intensity of irrigation for crop A. Okay, so we have crop A and crop A is covering an area of 40% of this total area. Okay, so area will be 40% of this total area is 1200. So simply find 40% of this total area. Simply find 40% of this total area. How much it is? 40% of 1200 is simply 12 for the 480. Okay. You can easily evaluate 40% of 1200 hectares. Okay. And similarly for crop B, it is 35%. Okay. So for crop B, I can again evaluate the area, sir. Okay. For crop B, I can again evaluate the area, which is nothing but 35%. So simply find 35% of 1200. Okay, so 35% of 1200 is 420. See, check this. If it is coming out 420, yes, perfect, 420. Okay, now it is saying both the crops are Rabi crops. Okay, both the crops are Rabi crops. That means both are simultaneously sown in the field in winter season. Rabi means winter season. Both the crops are present in the field at the same time. Okay, sir. Now they are saying crop A has a core period of 20 days. That means core period is 20 days and crop B has a core period of 15 days. Okay, sir. Now we have to calculate the discharge of the water course. If the core depth for crop A is, see, core depth is 10 centimeter and here core depth is 16 centimeters. So simply you have to find the discharge. Okay, so I have told you one logic. Okay, I hope you remember that logic. See, whatever, let us say this is our field, we are supplying water to the field. Okay, let us say we are supplying it with a discharge of Q for a time period of T. So how much water will be supplied to the field? Simple, discharge into time. This is the volume which you will supply it to the field. Now, whatever volume of water which you will supply to the field is Q into T will be stored there. So volume of water stored in the field is what? Area into depth. Yes or no? So this Q into T can be equated to A into delta because this is the volume of water which you have supplied to the field. Okay. And this is the volume of water which is stored there in the field. So Q into T is equal to A into delta. Simple. Okay. This logic you can apply here. This is very basic logic. Okay. Q into time period is area into delta. This is the volume of water supplied to the field and whatever volume of water you will supply to the field will be stored there. Yes or no? Simple. So from this equation, find the value of discharge. So discharge is, discharge we have to find for, see, this is the discharge for crop A. Time period is given as 20 days. You can convert days into second. You all know this. You all know that one day has 24 hours. Every hour has 60 minutes. Every minute has, okay, one day has 24 hours. Every hour has 60 minutes. Every minute has 60 seconds. Okay, so when you will multiply this, you will get it as 86400. So in one day we have 86400 seconds. We will write it here. Okay, see, obviously you need to put all the things in meter and second. Okay, in SI units. Now area is 480 hectare. We can write 480. Hectare is how much? 10 power 4. You all know that 1 hectare is 10,000 meter square. Okay. And delta is given to you as 10 centimeter. So we will convert this delta into meters. meters. I hope this is clear to you. Very simple. Okay, so from here you will get the discharge. Tell me how much you are getting. Tell me how much discharge you are getting. Similarly, you will apply this logic for on crop B also. Okay, you can apply this logic in crop B also. Tell me how much discharge you are getting here. You are saying 0.0277. Okay, 0.0277. 0.0277 meter cube per second you are saying. Okay, I hope this is correct. I hope you have solved it correctly. Yes, see, no, this is wrong. It is 0.277. Okay, this you are getting it as 0.277. So round it off. Okay, 7 will be repeated, so you can round it off. This much you are getting. Okay, I hope now you are getting it correctly. Okay, Priyansh. Now I think you have found out the answer. So it will be 0.278 meter cube per second. Okay, simply now find for crop B also. Find for crop B also, and remember this concept. Okay, Q into T is equal to area into delta. So we are getting it as, in the second part, if we will find the discharge for B, time period here is 15 days. In a single day we have 86400 second. Area is 420 hectares. Delta is 16 centimeters. So the discharge which you are getting here is how much? 0.5185 you are telling. Yes, 0.5185 is 0.519. 0.5185 is 0.519. Absolutely correct. So what I will do? We have two discharges. Both are there in the option. What will be the answer here? Can you tell me what will be the answer here? See, since both of these crops are okay, since both of these crops, you need to understand, since both of these crops are there present in the field simultaneously, that's why what we have to do is, okay, since both of them are present simultaneously, we have to add the discharge. We have to add the discharge. I hope this is clear to you. Why we have to add? Because both of them are present simultaneously. Is it clear? Both of them are present simultaneously in the field. That's why what we have to do, we have to add it up. If they are present in different seasons, okay, if they are present in different seasons, then we would have taken the maximum value. Okay, then we would have taken the maximum value, but here you need to understand, so we will take sum. So when you will sum it up, you will get it somewhere around 0.8. Okay, because both of them are present in the field together, so we have to add it up. We have to add them up. Is it clear or not? Yes, absolutely correct. 0.8 is the answer. I hope this is clear to you. Yes, supplied is equal to stored. Perfect. So you can simply add it up, you will get the answer. Because both are Rabi crops, that's why we are adding. So simply find QA plus QB, which will be nothing but 0.8. Okay, because in the field, both of them are present side by side together. Okay, if they were in different seasons, then obviously we'll take maximum, because we have to supply water Obviously for maximum one we have to take care of. Obviously the smaller one will be automatically taken care of. Okay, if they are in different seasons. In different seasons, if they were here, then 0.519 would have been the answer. Okay, so C is the correct answer. C is the correct answer. Okay, I hope this is clear to you. Now we have another question here. Now we have one more question here, so I hope. So in this question you can see, there are 5 crops. Okay, details of 5 crops are given to you. In this question you can see details of 5 crops are given to you, and water to those crops are being supplied from a reservoir. Okay, from a reservoir. Okay, so the base period intensity of irrigation duties of 5 crops are given to you, and water will be provided to these crops with the help of a reservoir. Okay, so let us say we have a reservoir. See, reservoir obviously means we have blocked a river with the help of a huge dam, and behind this dam huge amount of water has been stored. But this water will be supplied to all these 5 crops. But in the same time you need to understand that when this water is being supplied to these crops, okay, 20% losses are there and reservoir losses are 12%, which means that let us say if you have X amount of water, 12% will be lost here when it is stored, okay, in the form of seepage or something. So 12% are your reservoir losses, and 20% water will be lost when it will move from your reservoir to the field. Understood, sir? So now, sir, let us evaluate how much water is required in the field first. Okay, so see, we have 5 crops. Okay, we have wheat, we have sugarcane, we have cotton, we have rice, we have vegetables. So how much water wheat requires total? So that you can see, it is very simple. See, area is given to you. Simply multiply area into delta. Simply multiply area by delta and you will get total amount of volume. Yes, sir. Understood. So we will make a column for delta here. Okay. See, this we have this much space here. So we will write delta in this one. Okay, we have a space here. So see, delta is what? Formula for delta is how much? Duty is given, base period is given, and if I want to value delta is if I want to find delta in meter, it is nothing but 8.64 B by D. I hope you know this formula. How many of you know this formula? So here you will get delta in meters, base period you have to put in days, and duty is in hectare cube per cubic. Okay, so you will apply this formula and evaluate delta for each and every one. So put B is 120 and duty is 1800. So put 120 and 1800, you will get delta as, from here you will get the delta as how much? From here you will get the delta as how much? Tell me how much we are getting. Yes, so from here the value of delta which you will get in meter is 0.576. 0.576. Are you all getting the same value of delta? Yes or no? Similarly, find delta for all of them. Similarly, find delta for all of them. Tell me how much delta we are getting. 0.576 for the first one. Is it clear? Yes. Perfect. Now, similarly find for the second one. Yes. Similarly find for the second one. You will get it as, see, B by D. B is 360 days and duty is 800. Put 360, put 800, multiply by 8.64. Delta you will get it as 3.888. We are getting it as 3.888. So I hope you are able to understand this. Yes or no? Yes, 3.888 is the answer. Now similarly for cotton, similarly you can do for cotton. So for cotton we are getting it as 1.234. Okay. Similarly for cotton we are getting it as 1.234. Similarly for rice, 120 upon 900. Put 120 900 like that. Okay, we are getting it as 1.152. Similarly 120 and 700. Put 120 700, you will get it as 1.481. 1.481. Okay, so I hope this is clear to you. So these are the depths of water which are required at the field. So now multiply area into delta. Okay, this is hectare. Multiply this by this. Obviously, you will get the volume or not. So multiply this by this. You will get the volume of water required. See, volume of water required for each crop, we are finding it in hectare meter. Okay, we are finding it in hectare meter. So if I will multiply 4800 by 0.576, we will get it as, multiply it simple, we are getting it as 2764.8. Similarly, multiply 5600 by 3.888, how much we will get? We will get it as 21.21772.8 hectare meter. Similarly, for cotton, you will get it as 2400 into 1.234, you will get it as 2692.3. Similarly, for rice, you will get it as 3686.4, and simply for vegetables, you will get it as 2073.6 hectare meters. Okay, so these are the total volumes which you are getting. Now, if I'm interested in finding the total volume, okay, what is the total volume of water which is required by all these crops? And obviously, this water will come from reservoir only. Tell me how much is the total volume? Yes, perfect. Tell me how much is the total volume which we are getting here? Tell me what is the total volume of water which you are getting here? Tell me how much we are getting. If I will sum it up, we are getting it as, if I will sum it up, how much we are getting? No, simply add the total volume. Don't subtract the losses first. Okay, simply add it. All the volumes, when you will add it up, you will get it as 33259.9. Yes or no? When you will add this total volume, so total volume required by crops, okay, simply add them. It is coming out to be 33259 hectare meter. Okay, so this is the total amount of volume water required by these crops. Okay, simply you can sum it up. Wait a second. Okay, no space is there, so you can sum it up and get the answer. Okay, simply summing this, we'll get it. Okay, now if I want to find the capacity of reservoir, see in this question it is saying now how big the reservoir is. Obviously reservoir will be even bigger because 20% losses and 12% losses are also there. So if someone asks you what is your reservoir capacity, then what I will say? If I want to find capacity of reservoir, then obviously we have to divide this volume which is required by field or which is required by crops. We have to divide this by, see, first there is 12% loss in the reservoir and 20% canal losses when you are supplying it from reservoir to your field. So 12% means 88% efficiency and 20% means 80% efficiency. So divide it. How much you are getting? So now we will get it as, okay, we will get it as, so how much we are getting here? Divide it. It is very simple. Tell me, comment. Comment below how much we are getting here. How much we are getting here? We are getting it as, how much? 47245. This is coming out to be 47245 hectare meter, which means, see, this much amount of water should be there in reservoir. Okay, this much amount of water should be there in reservoir, and if from this total water, if 12% losses are there in the reservoir, and when water is transferred to your field, while transferring, let us say 20% losses are there, then the remaining water will be, out of this 47245, you will be left with, see, first you will multiply it by 0.88 because 12% losses are there. Then after that, let us say x is there. After that, you will multiply it by 80% because 20% losses are there. So whatever will be left, that is nothing but 33259.9. Okay. So total how much water should be there in the reservoir? Total how much water should be there in the reservoir? 47245. Okay. Approximately 47245. You can round it off. So reservoir capacity is 47245 hectare meters. So is the question clear to you? I hope the concept of efficiency is clear to you with the help of this question. Okay. Shall we proceed to the next one? So this is your reservoir capacity. Okay. Now we have question number 10. Solve this question number 10. I hope this is clear to you. Try to solve this. Excuse me. Okay. Yes, we have to find. Okay, so what we'll do in this question? Excuse me. Today, I think I am suffering from cold, so please bear with it. Okay, so now in this question, no, it's only little cold. Not much is happening to me. Okay, so plot of area is given to us. Amount of water supplied is given to us. Existing water content is given to us. Excuse me. Okay, so 16% is the water content which is given here. Okay. If the dry density of soil is 15 kilonewton per meter cube, root zone depth is 2 meter, what will be the field capacity? Okay. Assume water loss due to evaporation and deep percolation is 14%. Okay. So what we have to do here, see, you have supplied 500 meter cube water. You have supplied 500 meter cube water. So if you want to convert, if you want to find the weight of water here, see, water content is what? Weight of water upon weight of solid. So we will find weight of water and we will find weight of solid. Okay, like this. So weight of water here will be, weight of water will be what? See, this is volume. Convert volume into weight. How I will convert volume into weight? I have to multiply volume by density. Okay, I have to multiply volume of water by density. So volume of water is how much? 500 meter cube. Density of water you all know 9.81. It's not mentioned, but yes, we know it. It is 9.81 kiloton per meter cube. So tell me how much will be the weight of water? This will give you the weight of water in kilonewtons. Okay. So this will be how much? Similarly, I will find the weight of dry soil. Similarly, I will find the weight of soil solids. That will be what? Volume of soil into density of soil. Now volume of soil is how much? See, area is given to you. Area of soil into depth of soil. Root zone are 2 meters. So obviously we are interested in this 2 meter only. So multiply area by depth. Area multiply by depth is your volume, and density of soil is how much? 15. Density of soil is how much? 15. So this, tell me how much it is coming. Yes, you are saying it correctly. 4905. Okay, water weight is coming. Wait a second. Yeah, weight of water is coming out as. Also, one thing we have to do here. Okay, how much this is coming? Wait a second. 500 into 9.81. 4905. Perfect. And this is coming out as 15 into 12 into 1200 into 2. So this is 36,000. Okay. This is 36,000. Understood, sir. So you are saying the total weight of water which you applied here is this much, and this is your total weight of soil solids. Okay. Now you have to read this line. Assume water lost, total water loss due to evaporation and depercolation is 14%. So remove 40%, 14% from here. Okay. Now how much water will be actually applied? Actual weight of water which will be applied to the field is, you have to subtract 14%. So out of 100%, if 14% is removed, only 86% will be there. Yes or no? So find 86% of 4905. Find 86% of 4905. That will be simply 4218.3. See why we are subtracting 14%? Because out of this total water, 14% is lost. Only 86% is remaining now in the field. In the field, only 86% is remaining. 14% is gone somewhere. Okay, it is gone in the form of evaporation, deep percolation. Okay. So now, how much water content actually has increased? See, the level is 16%. So how much will increase? So we will find the water content here, weight of water upon weight of solid. See, weight of water is 4218.3 divided by total 36,000. So how much this is coming? Also multiplied by 100 because we want to find it in percentage. Okay. Okay, Jayesh. CSE gate. Okay. Yes. So how much this is coming? This is coming out to be 11.71. You are saying, okay. 11.71 something, but you can round it off to 11.72. You can round it off to 11.72. That means initially the water level was at 16%. Initially the water level was at 16%. Now you have increased how much water? You have increased it by 11. You have increased it by 11.72% after losses. This is the percentage which you have increased. So tell me where you will reach. Now tell me, after your water addition, what will be the field capacity value? Where you will reach? So add 16 to 11.72, you will get it as 27.72. Yes or no? So this is your field capacity. Okay, when you add water, obviously we reach field capacity. We are assuming here, if you add water, obviously you will reach field capacity. So A will be the correct answer. I hope you have understood this. Is it clear? Is it clear? Okay. Now we'll move on to the next question. This is question number 11. So here you have to find elementary gravity dam has a height of 105 meter. Okay. Specific gravity of dam material is given to you. Seepage coefficient at the base is given to you. C is given to you. Mu is given to you. Allowable stress of foundation is given to you. Consider the following statements. Okay. So you have to find minimum width of gravity dam for a case of no tension. You have to find minimum width of gravity for case of no overturning. You have to find minimum width of gravity dam for case of no oversliding. Okay, so I will write the formula and you will simply evaluate it here. Okay, I will write the formulas here. You simply evaluate it. So first is no tension case. Okay, so first one is no tension case. So for no tension, failure, first is for no tension failure. See, for no tension failure, the value of width is given by, the value of minimum width is given by h upon under root g minus c. Okay, second one is, second option is saying for no overturning. So for no overturning failure, minimum width is given by h upon under root 2g minus c. Okay, and for no the third one is for no sliding failure. Okay, third one is for no sliding failure. The formula for minimum width is, h upon mu g minus c. And the fourth one is for no crushing failure. So you have to remember these formulas in your elementary profile of dam. And for no crushing failure, the maximum height is given by maximum stress upon gamma w g minus c plus 1. Okay, so from these formulas, you will find minimum width of gravity dam for no tension. You will find minimum width of gravity dam for no overturning, minimum width for dam for no oversliding, and maximum height of gravity dam for no crushing failure. Okay, see, everything is given to you. Height is given to you as 105. Let me solve one. The very first one, see, height is given to you as 105. G is given to you as 2.5 and C is given to you as 0.8. You can see it from here. See, G is given to you as 2.75, C is 0.8 and mu is 0.75 and F max is 3.87. So this F max is given to you as 3.87 Newton per mm square and this mu is given to you as 0.75. Okay, height is given to you as 105. So you can put all these values and get the answers. So tell me how much this is coming. I hope you can read out all the values easily and solve it. Okay, I hope you can read it out easily and solve it. Okay. So how much we are getting it? So the first one, if you will solve it, okay, we have put the height here. Height is given to us as 105. Okay, G we have put, C value is 0.8. We'll put it here. How much we are getting it? Tell me. So when I have solved it, we are getting it as 80.53. We are getting it as 80.53. The second one, if you will solve, we will put the value of H as 105. Okay, we'll put the value of G as 2.5, C as 0.8. When you will solve this, we will get it as 56.94. See, also simultaneously check the values. The first one is saying 61.76, but you are getting it as 80.53. You are getting this value as 80.53, which means the first statement is wrong. Okay. In the second one, minimum width of gravity dam for case of no overturning failure is 56.94. Here also you are getting it as 56.94. This means second statement is correct. Now similarly we will find the third one. H is how much? Mu is 0.75, G is 2.5, C is 0.8. Everything is given to you in the question. So how much we are getting here? Tell me. Kindly comment everyone. How much we are getting here? 82.35. Okay. We are getting it as 82.35 meter. So let us check. Minimum width of gravity dam for case of no sliding failure is 82.35. Yes. So this is also correct. C option is also correct here. Okay. Now the last one. Now similarly we'll find the last one. So F max is 3.87 Newton per mm square. Okay. Gamma W is 9.81 or 9810 Newton per meter cube. See, units are different. This is mm square, this is meter cube. You need to convert, or you have to convert into same unit. See, mm, let us convert square into meter square, so that answer comes in meter. So see, this square, when you will convert into meter, it will be 10 power 6. It will be 10 power 6. Why? Because you all know that 1 you know that in 1 meter we have 1000 Okay. So we have to multiply this. We have to multiply this by 10 power 6, because 10 power 6 square are there in 1 meter square. So this mm square will get cancelled and unit will be Newton per meter square. Okay. Then this Newton will get cancelled. Meter square will get cancelled from here and answer will be in meters. G is 2.5. C is 0.8 plus 1. Okay. So how much maximum height we are getting here? What maximum height we are getting here? What maximum height we'll get here? If we'll solve it, you will get it as 146. 146. So let us check if the last option is 146 or not. For case of no crushing failure, the height is 146. No. If this would have been 146, then the fourth option would have been correct, but unfortunately this is wrong. Okay, so option D is correct here. Okay, if you have any doubt in this one, you can ask. I hope this is fully clear to you. So B and C option are correct here. This is an MSQ. B and C option are correct here. So in this one, you need to understand that we have to remember these formulas. Okay. We have to remember these formulas. Okay, now we'll move on to the next question. I hope you are you will remember these formulas. Okay, so these are this is the question number 12, which is saying consider the following statements here. Okay, consider the following statements here. So the first one is the value of residual seepage head. Okay, wait a second. The value of residual seepage head as per Khosla's theory seepage is more in the downstream half of the floor as compared to a brick sieve theory. This is absolutely true. Okay, this we have discussed in class also. Okay, so we'll discuss this. See, according to Khosla theory, if you will check, okay, according to Khosla theory, if you will check the residual seepage head, it varies like this. Let us say this is your barrage floor. Okay, let us assume this is your barrage floor. Now the seepage head is maximum at your upstream end. This is your upstream end. This is your downstream end. Okay, basically at downstream end the residual seepage head is 0, and at upstream end the residual seepage head is maximum. Okay, so in Blick's cube theory we assume that it varies in linear fashion, but in Khosla's theory we assume that it is varying in sinusoidal fashion, and you will see that it is like this, which means upstream in the upper half. Okay, this is your first half. So in the first half you will see that residual head is maximum, then residual head decreases. You will see that residual head is decreasing. Okay, I hope you can find this area. And here after the first half floor, you will see that in the second half of the floor you will see that more residual head is there. Okay, residual head increases. So the area of second half is more as compared to the area of first half. Okay, so you can say that this is the right answer. This first statement is correct. The value of residual seepage head as per Khosla's theory of seepage is more in the downstream half. Yes. See, this is your downstream half. This is your downstream half, and you can for sure see that in downstream half you have residual seepage head value more as compared to your upstream seepage half. Okay, upstream half. This is your upstream half. In upstream half you can see the residual seepage value is less, and here it is more. Okay, so first statement is very correct here, and also the residual seepage head is not linear, it is sinusoidal in nature according to your Khosla's theory. Okay, now since the value of slope of residual seepage head curve is infinity at upstream and downstream end, yes, you can see this is your residual seepage head curve. Slope at this point upstream point is infinity. Why? Because it is a corner, and this is also a corner. Here also slope is infinity, here also slope is infinity, and in between and in the intermediate you can find slope at any point. Let us say you are interested in finding slope here, so slope will be this one. Okay, you can find slope at any point. Okay, you can find slope at any point, it depends on you. Okay, but at the corners, at the upstream and downstream corner, at this corner and at this corner, slope is tending to infinite. Okay, so this is correct. Infinity at upstream and downstream end of floor, yes. Therefore water will definitely seep in soil at upstream end and will make an exit. Yes, absolutely correct. Since slope is infinite, that's why water will for sure, if your foundation is permeable, then it is for sure that water will enter from upstream and will exit at downstream. Okay, absolutely correct. So I hope this is clear to you. So residual seepage head, how it vary, residual seepage head curve I have drawn here as per your Khosla theory. Okay, so this is your residual seepage head curve. This is your residual seepage head curve as per Khosla's theory. Okay, so you can remember this. So first and second, both options are correct here. Okay, so the answer will be C. Both 1 and 2 are correct here. Okay, basic statements of Khosla theory. Okay, both of them statements are basic one. Okay, And this straight line is residual seepage head curve as per Blick's theory. So you can see that in the upper half, Blick's theory is giving you more value as compared to Khosla's residual head seepage, and in the downstream half, Blick's creep theory is giving you less residual head as compared to your Khosla one. Here Blick's value is less and Khosla is more, and in the upstream half, Khosla value is less and Blick is more. Okay, so C option is correct here. I hope this is clear to you. Now we'll move on to the question number 13. Okay, so you have this question number 13, and here we have a section of barrage. Various dimensions are given here, and we have to find the permissible exit gradient. See, exit gradient is very simple to find. Okay, exit gradient is easy to find because in exit gradient we have a formula. You know that exit gradient has a formula, simple h by d pi 1 by root lambda, and lambda you all know, lambda is 1 plus under root 1 plus alpha square by 2, and where alpha is b by d, where alpha is b by d. Okay, so now simply you need to do what? You have to find b, d and h. Okay, so we'll see this entire floor length is b. Okay, this entire floor length is b. Floor length is b. Now we have to find h. So what is h? You can see this is the maximum level of water on the upstream side, and you can see that here there is no water. This is 103.5. So 108.5 subtract 103.5 from 108.5. This is your, you can say, difference in level of water. Difference in level of water, which will be h here. H means the total head of water in the upstream and total head of water in the downstream. You have to subtract them. So h will be what? 108.5 minus 103.5. So when you will solve this, you will get the value of h, which is simply 5 meters. Okay, so we have total 5 meter of head of water, with the help of which this water will seep under this foundation. And then we have to evaluate the value of the length of downstream pile. So length of downstream pile is simple. See, this is the lowest point is 95 and highest point is 103.5. So 103.5 minus 95, this will give you the length of downstream pile. So 103.5 minus 95 is what? Is 8.5. So you have found out h, you have found out d, and b is 54. B means length of floor. So difference in head of water is there, depth of downstream pile is there, and your what is there? The length of floor is there. Simply put the values here. Now what will the alpha? Alpha is b by d. B is 54 and d is 8.5. Okay, alpha you will get it as 6.35. Okay, now put the value of alpha here. Put the value of alpha here. Okay, alpha is 6.35 square upon 2. So when you will solve these values, you will get the lambda. Lambda is coming out to be 3.716. And now put this lambda here. H is what? 5. D is what? 8.5. Pi you all know. And lambda is 3.716. So what is the value of exit gradient which you are getting here? Tell me. Solve it. How much value we are getting here? What is the value of exit gradient that we are getting here? So if you will solve this, you will get it as if you will solve this, you will get this value somewhere around 0.097. Okay, we are getting it as, yes, 0.097. Perfect. We are getting it as 0.097. And if you want to write it in 1 upon denominator terms, this will be 1 upon 10.3. Okay, so exit gradient we have solved. Okay, you have completed till water requirement, but you are lagging in canal design. So what should I do? If you are lagging in canal design, simply remember the Lacey formula. Okay, try to learn the Lacey's formula, basic Kennedy formula. Okay, just a glance. Okay, in single video you can revise it. In a single video you can revise it. Okay, don't need to worry. We will have a marathon on 30 and 31st also. So if you'll see the marathon also, then also it will be good. Okay, up to, see, basically up to water requirement question will be there. Okay, but sometimes from canal outlets they ask, sometimes canal design question is there. Okay, basic Lacey theory, basic empirical formulas. So if you'll try to learn the basic formulas only, then also it will be sufficient. Okay, so exit rate is 0.097. Yes, this is correct. Now we have to check if this section is safe against piping or not. Okay, we have to check if this is safe in piping. So what I have to do is, see, they have given you the safe value of exit gradient. The exit gradient safe value is 1 by 6. So check if this value is less than 1 by 6 or not. This is less. Yes. See, 1 by 10.3 is less than 1 by 6 or not. Tell me. Yes, sir. So exit gradient, which we are providing with the help of this diagram, is less than critical value, is less than safe value. And since we are less than safe value, we will say that piping will not happen here. So the section is safe against piping. And if we will change some parameters here, then obviously this value can go up. And if this exit gradient is more, then obviously your section will not be safe. But here you can say that it is safe because exit gradient is less than the safe permissible value. Okay, I hope this is clear to you. So A and C are the correct option here. Okay, now we'll move on to the next question. So this is a question from your CPM part. They are saying the total float value is non-zero for activity. See, first you have to find the critical path here. Okay, find the longest path here. Very simple question. Try to find the longest path here. So first you have to find the longest path. So let us find this path first. So if you'll find the total time of A, B, E, H, total time of A, B, E, H is how much? 5, 2, 7, 7, 4, 11, 11, 7, 18. Then let us solve for this one. A, C, F, H. A, C, F, H is giving you how much time? 5, 6, 11, 11 to 13, 13, 7, 20. Okay, now the third one, A, C, G, I. A, C, G, I. So 5, 6, 11, 11, 3, 14, 11, 3 is 14, 14, 2 is 16. So the biggest one is this one. Biggest one is ACFH. Critical path is your ACFH. Okay, so what we can do here is we can highlight it. This A, C, F, H is the critical path. So you all know, we have discussed this also, that on critical path, whatever activities are there, float is 0. Okay, so total float will be 0 for activities which are on critical path. Okay, and they are none other than A, C, F and H. And the activities which are not on critical path, such as B, E, G and I, and the activities which are not on critical path, such as B, E, G and I, they will be having non-zero float. They are non-critical activity because they are not on critical path. There we have more time. These are non-critical activities and these are critical activities. So there we have more time. You need to understand this. Okay. So on the critical path, whatever activities we have, there we have more time. So their float is 0. Okay. So float here will be 0. So I hope this is clear to you. So float will be 0. So they are saying total float is non-zero for which activities? So total float is non-zero for B, E, G, I. Okay. B is not there. G is there. E is there. I is there. So G, E, I. So for A, C and D, you will say that float is non-zero. Simple. Basic logic. Okay. You will say that float is non-zero. Is this clear? Now we have one more question. Okay, so this is the question. They are saying to find latest finish time for node. So latest finish time for node cannot be there. Latest finish time is for any activity. So this is a wrong question. Because see, you can see for a node, you can find earliest event time and latest event time. You cannot find latest finish time. Okay. So let's skip this question. Okay, so we have this question. Following data is given to you, and what you have to do, you have to find the critical path. Okay, so first what you have to do, you have to draw the network. Activities are given to you. Draw the network and find the critical path here. Find it simply. Very basic question. Simply draw the network diagram and find the longest path. So what I will do here is, we'll try to make diagram. So from 1, 2, 3 and 4 are coming out. So from 1, okay, wait a second. So from 1, 2, 3, 4 and coming out. Let us draw it here only. So from 1, 2, 3 and 4 are coming out. Okay, 3 activities are coming out from here. Okay, so this we have drawn. Now 2 6. So from 3 4 5 6 are coming out. From 3 4 5 6 are coming out. From 3 4 5 6 are coming out. Okay, from 3 4 5 6 are coming out. From 3 4 5 6 are coming out. Okay, so from 3 4 5 6 are coming out. From 2 we have to go into 6. From 2 we have to go into 6. From 5 we have to go into 6. From 2 6 5 6. So this is 2 6. This is 5 6. 2 6 5 6. Okay, last one is 4 5. Last one is 4 5. So we have to go from 4 to 5. So this is your total network diagram. Okay, now we'll write the times. So 3 4 14. This is having 3, this is having 4, this is having 14. Then 3 4 6. This is having 3 4 6. Then 2 6 having 5 and remaining are 1 1. 2 6 is having 5 and they are having activity time as 1. Okay, so now you have to find the longest one. So for 1 to 6, okay, you can easily find the longest one. See, this is having 8. See, ultimately we have to reach 6. So this is having 8. 4 and 6 is 10. Okay, let us write also. So 8, second path is 10. See, this path is 4 plus 4 8 plus 1 is 9. And this path is 4 plus 3 7. 7 plus 1 is 8. 8 plus 1 is 9. This path is 14 plus 1 plus 1 is 16. Yes, this is the longest one. This is the longest one. So out of total 5 paths, we have this as the longest one. Okay, so this is your first, the longest one. Total 16 days it is taking. Total 16 days it is taking. So if it is taking 16 days, then this will be the critical path. 1 4 5 6. 1 4 5 6 will be the longest one because it is taking how much time? 16 days. Okay, simple question, basic question. Okay, so is this clear to you? I hope this is clear to you. So this is your basic question. Now we have this one, minimum project completion time. So project starts with activity A. You can see we have starting activity A as A and ends with activity F. Okay, and the precedence relation and durations of activities are shown here. Okay, sir. So we simply have to draw it. Okay, so before A nothing is there, we will draw it. So before A we have nothing, and how much time A is taking? A is taking 4 days. Okay, understood, sir. Now before B C we have A. Before B and C we have A. Okay, sir. So before B and C we have A here. Okay, sir. So we have drawn this also. They are taking 3 and 7 time. This is 3. This is 7. Okay. This is taking 3 and this is taking 7 days. Okay. Now before D, B is there. Before E, C is there. Before D, B is there. And before C, E is there. Before C is there. They are taking 14 days and 4 days. And before F, D and E are there. Before F, D and E are there. Okay. Before F, D and E are there. And it is taking 9 days. So this is a very simple question. Now you simply have to tell like which is the longest path here. So see, this is taking 4 3 7. 7 14 is 21. 21 9 is 30. So the topmost path is taking 30 and the bottom path is taking 4 7 11. 11 4 15 59 24. Okay, so yes, the top one is your critical path. The top one is your critical path. So if this is your critical path, then obviously the total number of days which it is taking is 30 days. So minimum how much days will be required to complete the project is 30 days. Okay, minimum how many days we require is 30 days. Okay. Okay, now we'll move on to the next question, which is question number 18. So in this question number 18, for a construction project, the mean and standard deviation are given to you as, see, mean is given to you, mean is expected time only, or you can write it as mu. Mean is given to you as 220 days and sigma is given to you as 6.8 days. Okay, sir, assume normal distribution. Okay, so we will assume normal distribution. So this is your normal distribution curve. Obviously in between you have 220 days. Okay, for which you have z equal to 0. Okay, sigma is there and z is equal to 1.65, z is equal to 1.64, sorry, for 95% probability. When you have 95% probability, z is 1.64, which means this is a point where z is equal to 1.95 and the area behind it and area up to this point is 95%. This area total is 95%. Okay, because when z is 1.95, which is ahead of mean only. So tell me, what is the schedule time here? They are simply saying what will the maximum time required in days for completion of the project for z equal to 1.64 or for 95% confidence level. Obviously we can find this. We know the formula for z is ts minus te upon sigma. We'll put the value. Z is what? 1.64. ts schedule time we have to find. Okay, obviously the schedule time is more than 220, you can see it. Expected time is 220 and sigma is 6.8. So from here schedule time is 220 plus 6.8 into 1.64. 1.64. So you need to understand that for z equal to 0 or for schedule time equal to 220 days, the probability is 50%. Now you have increased that number of days, so obviously probability will also increase. If you have more number of days, the probability to complete the project in that amount of days is more. If you have less number of days, the probability to complete that project in that number of days will be less. Yes or no? So now when you will solve this, you will get it as 220 plus 6.8 into, we are getting it as 231.15. 231.15, or you can round it off to the higher side. So at least in 232 days we will finish it. At least in 230 days we will be able to finish it. I hope this is clear to you. Simple question. This is again also a simple question. So at least 232 days I require, so that the probability of completion is 95%. Okay, great. Yes, perfect. Now we'll move on to the next one. This is question 19. So in this question is saying, okay, so all the activities are drawn here, and in all the activities we have 3 time estimate. Okay, everything is given to you. So what you have to find? We have to find standard deviation of and variance of the project. Okay, this is very simple. See, first what we have to do, we have to find the estimate expected time for all of them. So expected time you can easily find. Okay, so for this first 2, 5, 14, let me tell you how to find expected time. You know the formula. It is T0 plus 4 Tm plus Tp upon 6. So optimistic time is 2, 5 and 14. So put 2, 5 and 14 and get the value of expected time. Get the value of expected time here. So it is coming out to be, when you will solve here, you will get the expected time as, 6. So the expected time is 6 for the first one. Okay, expected time is 6 for the first activity A. Okay, you can find expected time for all of them. So let me write here, it is 6. Similarly you can find for B, which is 6 again. Similarly you can find for C, which is 2. Similarly you can find for D, which is 4. Similarly for E, which is E, for E it is coming out to be, 8. Okay, for F it is coming out to be, for 4 5 it is coming out to be 4. For G it is coming out to be, solve quickly, this is coming out to be 6, and for H it is coming out to be 6. Okay, so this is your entire system. Now we have to find out the longest time. So 6 to 8, 8 6 14, 14 from this one, 6 4 10, 10 8 18, 18 10 28. This is the longest one, I guess. Then 6 8 6 is less, obviously. Then we have this one, 6 4 8 6. This is, so 28 is the longest one. Okay, so this will be the longest path. This one will be the longest path. 1 2 2 3 3 4 4 5 and 5 6. This will be the longest path, which will take 28 days. Okay, so now expected time of this project. So now the expected time of this project will be, what? 28 days. 6 4 10, 10 8 18, 18 4 22, 22 and 6 is 28 days. And if I want to find the variance of this project, so variance will be what? Variance is that we have to find variance of all these activities. First we have to find variance of A, then D, E, F and H. A, D, E, F and H. Okay, how I find variance? Variance is nothing but sigma square. Variance is nothing but sigma square. Okay, and how we find sigma? I hope you know the formula for sigma. Formula for sigma is Tp minus T naught upon 6. Tp minus T naught upon 6 whole square. So Tp T naught is given to you for all of the activities. So for A, 14 and 2 are there. So we will do 14 minus 2 upon 6 whole square. Similarly for D, we will do 5 minus 3 upon 6 whole square. Similarly for E, we will do 11 minus 1 upon 6. See, this is 11 minus 1 upon 6 is sigma. We have to do square because it is variance. For F, it is 10 minus 2. For H, it is 15 minus 1. This much. Okay, so you will get variance. So when you will solve it, the variance is 14.11. Let us check. So variance is 14.11. Yes, this option. Now variance is coming. Variance you all know is nothing but sigma square. Variance is 14.11. So sigma is what? Sigma of project is what? Under root. So when you will under root it, this will be 3.76 days. Okay, this is square. This is not. So 3.76 is your standard deviation. This is how you will find. Okay. Yes, I know. Okay, so the answer is this only. Okay, so this is your variance and this is your sigma square. So remember this central limit theorem. Second, so this is 19th question. Now let us take the last question. This is our 20th one. Okay, so this is your crashing one. This is your crashing one. They are saying what will happen after third stage crashing. So let me tell you. And have they given the activities? Yes, everything is given here. So see, the total cost initially will be 7 plus 4 11, 11 6 17, 17 8 25. Yes or no? 11 6 17, 17 8 25, 25 5 30. So the direct cost initially will be, initially when no crashing is there, project duration is what? Initially project duration, see, direct cost is 30,000. Indirect cost we have to find, but for that we have to find project duration. So from here you need to understand 6 5 11 days are happening. Here we have 13 days, and 6 plus 4 10, 10 plus 5 15. So along this path 11, along this path 13, and along this path 15. So this is the longest path. This is the longest path. 15 days it is taking. Indirect cost will be what? See, 3,000 per week, and you are solving it in 15 days. You are completing it in 15 days. If critical path is 15, then obviously project will get completed in 15 weeks only. So 3,000 every week, and you are solving it in 15 weeks. So answer will be, total cost will be how much? Total cost will be, you can add it. Total cost will be how much? 75,000. Understood, sir. Now we will do first stage crashing. Okay, we have to do it thrice. So here I will do stage 1 crashing. Here I will do stage 2 crashing. And after third stage, we have to tell the cost. Okay. After third stage crashing, I will tell. Now, we have to crash certain activities which are having the least cost slope. You know that it is taking 15 days. This path is taking 15 days. This is taking 13 days. This is taking 11 days. Okay. Now, first you need to understand. Let us find the cost slope of all of them. So, cost slope of all of them, I think we can find easily. Subtract this value from this. So 7500 divided by 3. 75 divided by 3 is 2500 per week. See, cost slope you all know, delta C by delta T. Then 4500 divided by 3, that is 1500 per week. Then how much value has increased? 3000, and that too in 3 weeks. So 3000 divided by 3 is 1000. Similarly, 8 15 gap is 7000 divided by 2, that is 3500, and here the gap is 6000 in 2 weeks, so it is 3000. Okay, simply divide the change in cost divided by your crashing potential. So now you can see that in this path 1 2 2 3 3 4, out of 1 2 2 3 3 4, which is having the least cost slope? 1 2 2 3 3 4, which is having the least cost slope? 1000. Okay, see, the least cost slope is being held by 2 3 2 3. You can see this is 2 3. So we will crash it by 2 days. We will crash it by 2 days. Okay, crash 2 3 by 2 days. Okay sir, why? Because it is along the critical path and having the least cost slope. Now why only 2 days sir? Because you need to understand, see, here it is taking 11 days, here it is taking 13 days, and along this path is taking 15 days. So I will bring down 15 to 13. Okay, first you will bring it down to 14, then 13. So directly you can bring down to 13 only. Then you will have 2 critical paths. Okay, if you will crash this critical path from 15 to 13, if you will reduce the time from 15 to 13, then you will have this critical path 13, and this will also be a critical path. Yes or no? So now project duration will be, now if this is 2, so 6 2 and 5 is 13, and 8 5 is also 13. So these two are critical paths now. So now the direct cost will be what? Sir, initially it was 30,000 for all activities, but since you have reduced this by 2 days, 1000 rupees will increase for every day, but you have decreased it for 2 days. So 2000 rupees will increase here. 2000 rupees will increase here. Why? Because for every week, 1000 rupees will increase, but you have reduced it by 2 weeks, so 2000 will increase. Okay, and in indirect cost will be 3000 into 13, because now project duration is, now you need to understand that project duration is 13 days, 13 weeks. Okay, so this is 39,000. When you will find the total cost, so total cost will be, sum this up, it will be 71,000, obviously lesser than the first one, so it is better. Now you need to understand, see, this is also having 13, this is also having 13. So now what I should do, I have to reduce it to 12 first, then 11. So let us see what we can do. So on this path, obviously this is having the least cost slope, so we can reduce 1 day from here. And if you are reducing 1 day from here, so on this path also you can reduce 1 day. Okay, see, this is one critical path, this is second critical path. If on this path I can reduce 1 day because this is having the least cost slope on this path, 1 2 2 3 and 3 4, this is having the least cost slope, so we can reduce this by 1 day. Yes or no? Yes sir, we can reduce by 1 day. And if this is reduced by 1 day, this will be 12, because initially it was 13, now it will be 12. Now we have to reduce 1 day from here also. So 1 3 and 3 4, out of 1 3 and 3 4, out of 1 3 and 3 4, out of 1 3 and 3 4, sir, 1 3 is good, we will reduce 1 day from here. 1 3 is good because we will reduce 1 day from here because it is having least cost slope. So 1 3 is this one, we will reduce 1 day from here, so we will make it 7. Now 7 5 12, and 6 1 5 is also 12. So now your project duration will be, see, I will write crash 1 3 and 2 3 by 1 day. And when you will do this will be 12, this will be 12, and this will be 11. So overall project duration will be 12 only. Project duration will be 12 weeks. Sorry, week should be there. So now your direct cost will be, if you will decrease this by 1 day, and if you will decrease this by 1 day, so 1000 rupees will increase here, and 1500 will increase here. So initially it was 32,000. Now 1000 will increase because of 2 3, and 1500 will increase because of 1 3. So total this will be 34500, and indirect cost will be 3000 into 12, which is nothing but 36,000, because total 12 weeks are there. So total cost will be this plus this 34, this is 70500. Now we'll go for third stage crashing. Now what we have to do, we have to reduce both of them. We have to reduce this path, we have to reduce this path to 11, because it is 11. Okay, so now you can see that nothing is left here. So what we can do, from this path we can reduce 1, and from this path we can reduce 1. Now obviously, you know, on this path this is having less cross slope, this is having less cross slope, 1500, yes or no? Yes sir. And on this path, out of 1 and 2 and 3 and 4, see, this is done, it has reached up to 1, so it is entire crashing potential has been used. So we have to check for 3 4 and 1 2. So for 3 4 and 1 2, crashing potential is less for this one. Okay, so for 3 4 and 1 2, crashing potential is less for 1 2. Crashing potential is less for 1 2. So we will decrease this by 1 day. Okay, and we will decrease this by 1 day. So what will happen here, this will take 11 days, this will take 11 days, this will take 10 days. Okay, so now I will crash 1 2 and 1 3 by 1 week. So obviously the direct cost will increase. Now the direct cost will be, initially it was 34500, now it will be increased. See, 1 2 will be increased because by 2500, and 1 3 will be increased by 1500. Okay, let us check for 3 4 also. 3 4 is having 3000, no, so we'll not touch that. Okay, here we will increase it by 1500 and 2500. Okay, this is 1500 and this is 2500. 1 2, so total how much will be the direct cost? It will be 4000 more, so it will be 38500. Now indirect cost is how much? Now we are completing the project in how many days? 11. We are completing the project in 11 weeks, so 3000 to 11, because for every week we are requiring 3000 rupees. So when you add the total cost, add this will be 71500. So after third stage crashing, the total cost which will be required here is 71500. Wait a second. 3 8 and 3 3, yes, 71500. So answer will be 7. Okay, have we done something wrong? If any calculation has gone wrong here. After third stage crashing, in second stage we have crashed 1 3 and 2 3. 1 3 and 2 3. 1 3 and 2 3 by 1 day. So 1 3 2 3, when they will be 2500 will increase. Yes, so it is correct. It will be 71500. Okay, 71500 will be the answer. Okay, the total cost. So I hope this is clear to you. Okay, this is how we will crash. Okay, so I hope the entire crashing logic is clear to you. So we will end here. Okay, we will end our session here. So I hope you have enjoyed it, and Thank you everyone. We'll catch up in next session. Now on your Gate Wallah MEC channel, you will have your marathons on 30th and 31st, where we'll revise hydrology, irrigation, BMC and CPM part. Okay, so I hope you have liked the session in which we have solved many questions. Okay. Okay, yes, I will try to get well soon. Definitely. Okay, only little cold is there. Nothing much to worry. Okay, you will get your classes regularly. Okay, so stay blessed. Take care. We'll catch up in the next session. Thank you, everyone.